In this lecture, we will work through risk management examples utilizing the methods described in this module. Solar Tech Innovations has been contracted to design and install a solar power system for a new community center in downtown San Diego. The project involves installing solar panels, inverters, and battery storage to provide clean energy for the facility. The project manager oversees a team of 1 solar tech engineer and 2 interns. The initial scope statement has been completed, and the next steps involve risk identification and management. The objective of the project is to deliver a fully operational solar power system that meets the energy needs of the community center within the agreed timeline and budget. We want to identify potential risks associated with this project, develop a risk assessment form to analyze identified risks, develop a risk response matrix to outline how you would deal with each of the risks, explain the reasons for the risk response type for each of the identified risks. In this graphic, we have identified 5 risks. 1. Supply chain delays. Delay in receiving solar panels and equipment due to supply chain issues. 2. Weather conditions. Adverse weather conditions affecting the installation schedule. 3. Regulatory changes. Changes in local regulations or building codes impacting project requirements. 4. Technical issues. Problems with the installation or malfunctioning of solar equipment. 5. Budget overruns. Unforeseen costs leading to budget overruns. Once the risks are identified, we can construct the risk assessment form. This form lists each risk along with its likelihood, potential impact, detection difficulty, risk value, and mitigation strategy. Here is a breakdown of each component. Risk description. Clearly describe each identified risk. This ensures that everyone understands the specific issues that could potentially impact the project. Likelihood. Assess the probability of each risk occurring. This can be rated on a scale. For example, low, medium, or high to provide a clear understanding of how likely it is that the risk will materialize. Potential impact. Evaluate the potential impact of each risk on the project. This assessment should consider factors such as cost, time, scope, and quality. Detection difficulty. Determine how difficult it is to detect each risk. This helps in understanding how easily a risk can be identified before it impacts the project. Risk value. Calculate the risk value for each risk. This is typically a function of the likelihood, impact, and detection difficulty, and helps prioritize the risks based on their overall threat to the project. Mitigation strategy. Develop a strategy to mitigate each risk. This should include specific actions that can be taken to reduce the likelihood of the risk occurring or to minimize its impact if it does occur. By systematically evaluating and documenting these components, the risk assessment form provides a comprehensive overview of the potential risks to the project and the strategies in place to manage them. This proactive approach helps ensure that risks are identified early and managed effectively, increasing the likelihood of project success. The risk response matrix is a crucial tool for managing identified risks in a project. It provides a structured approach to ensure that each risk is appropriately addressed, mitigated, and monitored. For every risk identified in the risk assessment process, the matrix details the following components. Risk description. A concise statement outlining the nature of the risk, its potential impact on the project, and the likelihood of its occurrence. Response type. This defines the overall approach taken to address the risk. Common response types include avoidance. Eliminating the risk by changing the project plan. Mitigation. Reducing the impact or likelihood of the risk. Transfer. Shifting the risk to a third party, such as through insurance or outsourcing. Acceptance. Acknowledging the risk and deciding to accept the consequences if it occurs, often used when the cost of mitigation is higher than the risk itself. Response strategy. A detailed description of the specific actions to be taken to implement the chosen response type. For example, for avoidance, the strategy might involve altering project scope or timelines to eliminate the risk. For mitigation, it could involve implementing additional quality controls or safety measures. For transfer, the strategy may include purchasing insurance or outsourcing certain project elements. For acceptance, the strategy might be to monitor the risk and prepare for its potential impact without active intervention. Contingency plan. This is a backup plan detailing the actions to be taken if the risk materializes despite the response strategy. The contingency plan ensures that the project team is prepared to manage the impact of the risk and minimize disruptions. It often includes specific steps to follow when the risk event occurs, allocation of resources and responsibilities for managing the risk impact, communication plans to inform stakeholders about the risk event and the actions being taken. By systematically documenting these elements for each identified risk, the risk response matrix helps project managers and teams proactively manage uncertainties. This ensures that risks are not only anticipated but also addressed in a structured and efficient manner, minimizing their potential impact on project success. For the risk of supply chain delays, the response type is transfer. This approach involves establishing contracts with multiple suppliers and setting up priority agreements, thereby transferring the responsibility for ensuring timely delivery to the suppliers. By diversifying the sources and providing fallback options, this strategy mitigates the impact of delays from any single supplier. Additionally, the contracts often include incentives for suppliers to prioritize your project, which helps reduce the likelihood of delays and ensures more reliable delivery schedules. For the risk of weather conditions, the response type is mitigate. Although adverse weather cannot be controlled, its impact can be minimized by scheduling installations during seasons with more favorable weather. Incorporating buffer time into the project schedule helps accommodate potential weather-related delays, thereby reducing their overall impact on the project timeline. For the risk of regulatory changes, the response type is avoid. Staying updated on local regulations and building codes, and working closely with local authorities helps to prevent non-compliance. By proactively ensuring that all project plans and actions adhere to current regulations, you can avoid the risk of incurring costly and time-consuming changes later on. For the risk of technical issues, the response type is mitigate. Implementing rigorous testing and having a technical support team on standby can help mitigate the risk of technical issues. Thorough testing can identify potential problems before they occur, and having experts available ensures that any issues that do arise can be addressed quickly and effectively, reducing downtime and project delays. For the risk of budget overruns, the response type is accept. Some degree of budget overrun is often inevitable in complex projects. By closely monitoring the budget and maintaining a contingency reserve, you accept that some overruns may occur but are prepared to handle them without significantly impacting the project. This pragmatic approach ensures that the project remains financially viable even if unforeseen costs arise.